of 3, theoretical probability. So we will go through some different types of probability here. Tomorrow's lesson deals with experimental probability, another way of calculating the likelihood of an event happening, but using some different type of data to find out probability of an event. Odds and fairness, Monday's lesson there. Yet again, another way that probability can be represented. We'll still need to know the number of favorable outcomes, but unfavorable outcomes will be the other thing we'll be interested in. Compound events, that deals with multiplying two different probabilities together. There's similarities to the counting principle. And then the last two, permutations and combinations there. We've, in a sense, already saw permutations and combinations where order matters, order does not matter of type of stuff here. So, and that concludes the chapter once we get to that point there. So, do our vocab here. So we talk about when you're dealing with any sort of probability, what you care about is the probability, and again, it's up here, but probability of an event. What does that look like? So on and so forth here. So measures how likely the event is to occur. And for example, like you can see how they kind of write on, this is pretty much the standard form for how probability is represented, but when you're figuring out probability, just if I would say flipping a coin, and I said, well, what's the probability of flipping heads? Well, I would write this P right here, that means the probability of, and then usually in brackets here is whatever you're talking about here. I guess I could just say heads. So that would be asking a probability of getting a heads. If I was rolling a die and wanted to know the probability of getting a 2, I could write the probability of 2. If I was rolling a die and said, what's the probability of getting not an odd number, I could say probability not odd. So we'll talk about this not scenario here in a little bit. But this is how probability is generally, theoretical probability is represented. Experimental probability will look a little different here. But probability of an event there. So theoretical probability. The ratio of favorable outcomes to total outcomes. Okay. So if I said, going back, like flipping a coin here, for example, said, say the probability of heads again, do the same things here. So if there was a formula per se, this is it. It's the number of favorable outcomes always on top, and then the number of total outcomes on the bottom. So these answers are going to come out in fraction form. And probability is usually represented in fraction form, but it's also more clearly understood as a percent, such as 30% likelihood of the event or 28%. So, but you'll start with a fraction here. It'll always start with a fraction. And in this lesson here, when we get to the second part, it'll say find the probability write the probability as a fraction, a decimal, and a percent. So we'll start everything writing them as fractions here, but then you'll want to convert that fraction to a decimal and ultimately turn that decimal into a percent. This shouldn't be a new concept. We did this in the percents chapter in the first lessons there, converting between the three different forms, percents to fractions and decimals, and no doubt remember doing that type of stuff, but I'll refresh you on exactly how that works. But probability is almost, well, all three forms have their thing, because if we go back to our first lesson, remember we had that little 0 to 1 grid there. We talked about how in decimal form there, all probability is referenced in that decimal form. But, of course, there's ways to convert decimals, fractions, percents. They can all be interchangeable pieces here. So, different types of questions, different types of probability, want different types of forms. It's not really a huge focus for us this year, but it's just how that information is easily and best conveyed can be different depending on the audience that you're speaking to and what exactly you're using this information for. But things will always start in this fraction form here. So if I said the probability of getting a heads, so we talked about it off camera here, but how many total outcomes are there if I flip a coin? 2. I could get a heads or I could get a tails. So that's my bottom number, total outcomes. You can use tree diagrams, the fundamental counting principle. Both of those are used to find how many total outcomes there are. And that's basically what we did the first two lessons. We explored both ways to figure out how many total outcomes there were and go through the lesson and say, well, how many different outcomes or choices were there for different types of things. So then on top, number of favorable outcomes. So there are two things that could happen when I flip a coin. I could get the heads, I could get the tails. But how many favorable outcomes are there? 1, which of course is the heads. The tails is the unfavorable. So the probability of getting a heads is a 1 in 2 chance. 1 in 2. If I go back up to here, the probability of rolling a 2. So how many outcomes are there if I roll the dice? 6. And how many of them are favorable? 1. There's just 1, 2 on a die here. If I say, again, rolling a dice, and I say not odd. So how many total outcomes are there?
6.
There's still 6, because I could get the 1, the 2, the 3, the 4, the 5, or the 6. So when I'm saying not odd, what am I also saying, in a sense? I'm saying even numbers, because that's not the odd numbers. So what are my winners? 2, 4, 6. 3 winners, right? So I would say 3 and 6, but probability is always simplified. So this is, again, there's a 3 and 6 chance, but I would always simplify that like I do any fraction here. I should come up with 1/2 there. What if I said the probability of not getting a 2? Rolling a dice, what's the probability of not getting a 2? Not rolling a 2. 5 and 6. What are my winners? 1, 3, 4, 5, and 6 are all winners. As long as I don't get the 2, I win. So then you figure everything else is a winner for me. So if I said probability of not 2, 5 winners, and of course the one loser in that scenario would be the 2. That's what I don't want to have happen there. If I get the 2, I lose. So we'll see these not type of events going on here. We'll talk about in just a second here complementary events and things like that. So complementary events. Okay. Both events cannot occur at the same time. And how do I want to write this here? I'm going to write it this way. Equals 1. And I'll explain that here in a second. So complementary events, both of these events can occur at the same time. So if I just said, we'll go back to the die here, the probability of, we'll say, getting a 3. So if I said the probability of getting a 3, which rolling a dice is what? Probability of rolling a 3 on a dice. Eve?
5. 6.
Huh?
6.
Probability must have two numbers here. It's a ratio. Ratios always have two numbers. I'm comparing the number of favorable outcomes to the number of total outcomes. So the probability, how many things could happen when I roll the dice? How many outcomes are there? 6. And how many of them are favorable? 1, getting a 3. Plus the probability of not 3. So, Sam, how many outcomes are there?
6.
And how many of them are not 3s?
5.
5. And if I add those two events together, 1, 6 plus 5, 6, what do I get for an answer? I guess I get 6, 6, but if I simplify that, I get 1. In a sense, when you're talking about a complementary event, whatever the opposite of the event is, I mean, think about it like flipping a coin. If I said probability of getting a heads and the probability of not getting a heads, because what else could happen? I mean, there's really either like this, either I'll roll a 3 or I won't roll a 3. There's nothing else that could happen, right? I mean, what else other scenario is there out there? Either I'll roll a 3 or I won't roll a 3. The odds of rolling, or the probability of rolling a 3 plus the probability of not rolling a 3 is always going to equal a certainty. So when they're talking about these complementary events here, and again, we're saying that both of those things can't happen. If I roll a dice, I can't both roll a 3 and not roll a 3, right? I mean, one or the other is going to happen here. Either I roll it or I don't roll it here. So you'll be asked about complementary events again. I'll tell you right now, this mutually exclusive stuff, disjointed events, overlapping events, it's just, I'm not worried about going through all that stuff with you. So let me just look here and see. I don't really think they even ask you much about that type of stuff, but you will be asked about the complements. Stating what the complement is, we'll practice that there. But again, they have all these other things here, this stuff here, but it's just Venn diagrams. Right, so we don't need to get that deep into this here. Okay, why don't we flip over to our notes. And let's start working some out here. So, looking at 377, 378, 3, and 1 through 12 here. So, the scenario they're presenting is marble is chosen from a bag. There's 2 blue marbles, 3 green marbles, 6 red marbles, and 1 white marble. Find the probability of each event. So number 3 says the probability of pulling out a red marble. So 2 things I need to know. What are the 2 things I need to know to figure out the probability of this, Colin?
The total outcome
Total outcomes.
and favorable.
Right. So how do I figure out how many total outcomes there are?
You count up all the,
Yeah.
you add up all the
How many marbles are in the bag?
12.
And right, 2 plus 3 plus 6 plus 1 is 12. So first thing you should probably figure out or realize is when you're going through this here, writing your fractions out, all 12 of these are going to be over 12. I mean, 12, 12, 12, 12, 12, 12, 12, 12, 12. I mean, there's 12 marbles in a bag. That never changes throughout this part here. But what's going to change, of course, between each question is what we're going to have on top, because they're all asking different type of scenarios here. So question in this case says probability of getting a red. How many red marbles are there, Colin?
6.
There are 6.
And then simplify it.
I get 6, 12. And then, right, I would simplify that too.
1.
And there's the probability of getting the red marble. 1/2. Probability of not blue. And again, I could consider this a different way. If I'm saying not blue, I could say the probability of getting the green or the red or the white. So those are my winners there, right? As long as I don't get blue. So, Faith, what's the probability of not blue?
5/6.
Right. And of course, before you get there, you'll start with your 12. And you can do it a few different ways. This is the same thing as I said, the probability of green or red or white. Because all those things are winners there. These are one and the same here of what I just wrote here. So you can figure it out two different ways. I mean, you can count up the green, 3 plus 6 plus 1, there's your 10. Or you can just know that there's 12 total outcomes. If I just subtract off the blues, the losers in this case here, 12 minus the 2 blues also gives me 10. So you can either add up all the other things or just subtract whatever you don't want to have happen from the number of total outcomes. But 10/12 is correct, and then again, she simplified it as she should. Probability of that event's pretty good. So not a certainty, of course, but it's more likely than not, 83%, that you would pull not a blue marble out at random. But could happen though, right? Okay, number 7. What is the probability of pulling a yellow marble out? Sam?
0/12.
Yeah, still over 12. As we said, there's still 12 outcomes, but none of these are yellow marbles. So something that has no chance of happening, we would say, is impossible. So you could write 0, you could write impossible. Again, simplifying up there, but yeah, 0/12 simplifies to 0, or it's just impossible to happen there. Number 11, the probability of getting a white or blue. White or blue. What is the probability of getting white or blue? Eve?
26.
So it starts over 12. How many white marbles do I have?
0.
Oh, I have a white marble.
Where? Oh, 1.
So there's 1 in 12, or blue. So then I can add these two. How many blue marbles do I got? 2, or I got a 2 in 12 chance there. So what's 1/12 plus 2/12? 3/12. So there's my probability, and that simplifies to 1/4. That's my probability. So when you get these or scenarios here, again, we are talking about adding, because as long as I get the white or the blue, I win. So white's a winner, blue's a winner. How many white and blues are there? 2 blue plus 1 white give me 3 of the 12 are winning marbles. So 3/12 is where I would come up with for that one there, and then simplify. Good with this? Okay. Next part. So same general concept going on here, finding the probability, but now we got this spinner over here. 1, 2s, 3s, and 4s. Not all the numbers are on there the same amount of times. But two things we gotta do. So one, write the probability as a fraction. That's what we should do first. Then we're gonna convert it to a decimal and convert it to a percent. So number 15. Probability of a 5, that's 0, right? So let's look at 17. Probability of spinning the 2. Put you all back in the cup here. So same question as we started the last time. What things do I need to know to find the probability of spinning the 2? Faith.
The amount of thingies and then which one, like amount of the one.
Right. And how many thingies are there?
8. The bottom one is 8.
Right. Again, you just count out how many spaces there are. 1, 2, 3, 4, 5, 6, 7, 8. So as we go through all these sections here, bottom number of all our fraction will always be 8. Because again, not changing the number of, there's 8 total. One of 8 things is going to happen here. So that is true. And then how many 2's do we have on the spinner?
2.
Count again. Anybody?
3.
There are 3. 1, 2, 3. There are 3 2's on the spinner. So the probability of me spinning a 2 is 3 and 8. So there it is as a fraction. How do I turn the fraction into a decimal? What do I need to do?
Dividend.
Right. And again, you have your calculators here. Fractions are always just division problems of themselves. So you take your numerator, which is 3, divide it by your denominator, which is 8, 3 divided by 8, and there it is as a decimal, 0.375. So now I've turned it into a decimal, and you always want to turn into a decimal first. And then how do I turn that into a percent?
Move the decimal. Move the decimal so it's
How far do I move the decimal? 2 spots to the
right.
This
right. So I just 1, 2, so 0.375 as a percent, 37 and a half, or 37 and 5/10% here. So still simplify your fractions. That still happens. 3/8 is the same as 6/16. If I would divide 6 by 16, I get, again, the same decimal. It's not going to change the value of your fraction here. But still simplify. Get it into your decimal form next, and then turn it into a percent
Good
finally.
question.
Yep.
So if you multiplied it and then it was a fraction that you could still multiply, would you multiply it again or simplify it again, or would you just keep it how it was?
The fraction?
Yeah, like if that was like if there was something of it, like if you simplified that, if there was an even number of
Like if it was this?
yeah, and then you simplified that, and then and then that fraction you could be able to simplify again.
If I took like 4 divided by 8, I would get 0.5. If I took 1 divided by 2, I'd also get 0.5 here. So whatever of these are going to be the same decimal for you, and they'll be the same percent. But yeah, you always just simplify it. I mean, just like everything we've talked about since 5th grade, you just always simplify fractions here. So, I don't know if I answered your question exactly here. Still don't know exactly what you're asking. Does anybody know what she's asking me? You want to try ask again, or?
Well, 6, it's 8 over 12,
Yeah,
and then you
Yeah.
simplify that to 4 6. Would you simplify that again?
now I see what you're saying.
Yes.
Yes, you would.
Okay.
Because if I found the greatest common factor between 8 and 12, it's 4. So if I divide both of them by 4, I get 2/3. But if I divide by 2, dividing by 2 twice is the same as dividing by 4. So 4 is 6, but then I'd look at it and go, wait a second. That could still be simplified further. So yes, you always want to get it so a fraction is simplified when the only whole number that divides into both the numbers is 1. If I can divide anything other than 1 into both the numbers, then it can be simplified further. And again, you get into like one of these types of things here where you may not know the greatest common factor is 125. It is. But if I divide both of them by 5, I get 25 over 200. If I divide by 5 again, I'd get 5 over 40. And then if I divided by 5 a third time, then I'd finally end up to where I want to go here. So truthfully, I mean, as long as you can realize, do the two numbers, do they divide by 2, 3, or 5, you can pretty much simplify everything you need to in bits and waves here without wasting time finding greatest common factors all over the place. Don't tell Mrs. Barkley I said that. She's a diehard. You must use the greatest common factor. Doing this is wrong, and you know, you may go to the underworld after your life is over here if you do it that way. It's just so wrong. Just so horribly, horribly wrong. But I'm more of a just breaking it down in pieces here. And again, I would think looking at this, you could be like, oh, those numbers divide by 5. Oh, wait a second, those numbers divide by 5 too. Oh, hey, guess what? Those also divide by 5. So all I really would care about is, did you get to here in the end? If you did, I love how you did it. Whether you just divided by 125 right up here or divided by 5 3 times in a row. Both of those get you to where you need to go, right? My mind. So I also think it's just easier. Otherwise, we got to start building factor trees here. Remember the old those? I won't do it for you, but I could.
Yeah.
You know, and then begin the process here. Multiply whatever's in common to all the trees, so on and so forth there. But it just seems so obvious. I could just divide these things by 5 a couple times and get there without doing all this work. A lot of work to build these trees in my mind. So, and this is an easy one here. I mean, again, if you get some, not saying, but 368 over 59,154, and for all I know, the greatest common factor is like 1,024 or something in there. But who's ever going to find that? You know, it's like, you know. So I'd probably just start dividing these by 2 and see where I'm at, and then go from there with it. Okay. 19. Probability of getting less than 3. Probability of getting a number less than 3. Eve, what do you think? So what are my winners?
2 and 1.
Right. So how many 2s do I have?
3,
And how many 1s do I have?
2,
So how many total winners? I got 5 over how many outcomes?
8.
8 as a decimal. Of course, 3 is not a winner. 3 is not less than 3. 3 equals 3. So 3 is not a winner here. The only winners in Eve was spot on.
And 0.625.
Yep, 0.625, and then as a percent.
62.5%.
Yeah, just like that. There's my 3 numbers that I'm looking for right there. 5/8, get it in your fraction form first. Then you can use your calculator, convert it to a decimal, and then just move that decimal 2 spots right to turn it into a percent. 21. Colin, what's the probability of getting an even number?
Uh, 50-50. No.
Well, 50-50 is not how I would write that.
1/2.
But you are right, so.
1/2, 0.5. And then
So officially,
Four.
where we start, there's 8 outcomes, and again, the 3 2s plus the 1 4, that's where his 4 came from there, so you're not wrong in anything you said here, but just to make it clear and explicit for the camera. But yeah, there are 4 winners, the 3 2s plus the 1 4, and then again, he simplified it accurately as a decimal
5,
and as a percent.
50%.
What?
50%.
Right. And of course, you got to move your decimal 2 spots here. So it's up to you to just make sure you add that place value 0 there. 1, 2, that's where 50%. Don't write 5%. 5% is 1/20, or 0.05, so. 23, what is the probability of getting an even or odd number? Sam?
I think it might be 8/8.
8/8, you come, very good, Sam. So if I simplified that, 1 as a decimal, what? Still 1 as a percent, 100%, right? So again, 1,
Well, that was
officially there's my decimal right there. On my own, just like with the 5, if I move it, there's where the 100%, so. Goes back to 12/1, when we built that 0 to 1 type scale, 1 equates to 100% here, so. But yeah, I mean, what else could happen? Right? Okay, good with that? All right, last part talks about these complementary event type things here. So we'll just look at 25 here, and then we can do 27. So they say tossing a coin just once, what's the complement, or what's the opposite, is what I'm saying here. So if it said landing on heads, the complement is whatever the opposite of that would be, which of course would be landing on tails. And then the probability, you're finding the probability of whatever the complement is. So I'm asking you, what's the probability of landing on tails? 1 and 2, 0.5, 50% here. So 27 says, not landing on heads, nor landing on tails. So what is the opposite of that event?
Landing on heads and landing on tails.
Right, that's the opposite. So I would write landing on heads or landing on tails. And what is the probability of me landing on heads or landing on tails? Yeah, 2/2, which simplifies to 1, which simplifies to 100% here. So I'll just give briefly here, I'll just create it. We'll just say rolling a die here, and same deal. We'll just do a couple of these. Rolling a die, 1 through 6. So state the complement, find the probability of the complement event. So if I say the probability of rolling a 3 or 6. So what is the complement of that? Or what is the opposite of?
Not rolling on.
Yeah, I would say not 3. And they use this nor word, or you could just say or, I don't, but nor. Not 6, right, that's its opposite there. And what is the probability of this event right here? Right, because 1, 2, 4, 5 are my winners. Not 3, not 6, so therefore 1, 2, 4, and 5. So the probability of its complement is 4, 6, which 0.6 repeating, 66.6 repeating as a percent, if they did it that way there. Right. What if I said the probability of not 5? So what is the complement of this event? No, just be the probability of rolling a 5 and 1 and 6, 0.16 repeating, 16.6% repeating. Right. So you see how that works there?
Yeah.
With it there. Okay. Try a word problem here.
No. Yeah.
All right. 29. Probability that a spinner lands on red is 5 and 8. The spinner has 8 sections. What does this tell you about the number of sections that are red? What does it tell you about the number of sections that are not red? 5 of the sections are red, and how many are not red? 3. Okay, that was pretty tough, huh? Tough one. All right. We'll try 31 here, and then we'll be done here. So let's see. What do they want here? Let me just read 30. You're playing a game that uses a number cube. You need to roll a 4 or 5 to win. find the probability of rolling a 4 or 5. Then, describe the complement. So what is the complement of rolling a 4 or 5? Then, calculate the probability of the complement in two different ways, using the definition of the complement, using the definition. You don't need to, again, we're not talking about mutual, so all you need to do is find the probability of rolling a 4 or 5, and then tell me what the complement of rolling a 5 or 4 or 5 is, and then find the probability of that complement. Very similar to what you're doing here. Think you can do that on your own, that one? I hope so too. Don't care about this mutually exclusive thing here, or definitions here, so. Find the probability of a 4 or 5, list the complement of rolling a 4 or 5, probability of the complement. 31, last one. Pick a marble out of a bag. In the bag there are 12 red, 14 blue, 8 green, 23 white, 13 yellow, 30 orange. What is the probability you do not pick a white or red? So probability of not white, not red. Again, you should be able to figure this out. If you think she has it, I'll take the poll in just a second here.
Are we supposed to get a decimal and percent too, or just?
No, you can just leave it in fraction is fine here. So basically they're saying not white,
And not red.
not red. So, same thing we've done. Couple things I need to know. Give you a moment and then I'll take the poll. What do you think?
Do you want both answers?
It's just one answer here. Simplified.
13 over 20.
13 over 20. Sam?
Got that.
Same? Faith?
1 half.
1 half. Colin?
I got 7 over 20.
7 over 20. Okay. So let's see what we got. So,
Got it right.
what do we need to figure out first?
Amount of,
Yeah, we need to know how many marbles are in play here, and how many marbles are there? There are 100. So, again, I could certainly just add up I can do it two different ways. I can add up the reds plus the blues plus the
Oh, I did
greens plus the yellows.
There's no red marble.
Oh,
no.
there's no red marble at all? No,
No,
not
I-
red,
I'm
not
wrong.
white. Oh, wait a
I know
second.
what it is.
Alright,
I found the probability of
orange.
getting a red,
there we
or
go.
of getting.
So there I am adding up the blue, the green, the yellow, and the orange. And that gives me 65, right?
Yeah.
So I could certainly do with that. Or I could just go, okay, there's 100, and then I can subtract how many are red, 12. Subtract how many are white, 23. And that also will give me, so whatever way's more comfortable for you there, add up all the ones that are winners or just subtract the losers. But regardless which way you go, you should get 65 over 100. Both of those numbers can be divided by 5, 13/20ths. You
I-
stated the complement.
Yeah, I found the probability of getting a red and white.
You found the probability of getting the white or the red. That would be this, because that's its complement. And your 1 half, I'm not totally sure what you did there,
didn't
but
add the orange.
I'm not. Well, as you can see, I had my own error setting it up too, so I feel pretty confident you know what you're doing though, so, right. Okay, anything else here?
No.
Okay. All right, cool beans.
Ah,
What face is that there?